Howdy, folks, and welcome to another episode of Cedar Craft. Today we have a real treat especial. We're going to be talking with Oliver Flatt, who's been working this summer at Amazon on Cedar, figuring out how to make entity slicing work better. So, if you've never heard of entity slicing or unfamiliar with what that challenge is, this is the episode for you. And I think this is a really exciting bit of technology that's going to be important for the future of Cedar, speeding things up and also making deployment easier. So Oliver's also a PhD student at the University of Washington, working in programming languages and compilers. Um, Oliver, please, any additional intro stuff that I missed?
Oh, thanks for having me. Excited to talk about entity slicing and what my internship ended up doing. So, I guess I'll go ahead and start by introducing what entity slicing is. I'll just pull up the public RFC here. Yeah, so here is the RFC that I wrote about halfway through my internship. It is on this problem called entity slicing. Basically, Cedar has this big problem, which is that users don't know what data to give to Cedar. It's correct and sound to give your all of the data that you have at once, but in some cases that may be inconvenient. For example, if you're like a client and you have all your data on the client side and the server has the schema and policies and it needs to decide your authorization requests, then it's going to be really inconvenient to send all your data across the network. And so in this picture, I have the client just sending an entity slice, which is part of the data, just the part that the server is going to need to make a decision. So that's the idea, sending some of your data, not all of it, just enough that the server can make a decision using your Cedar policies.
And so maybe to set some context for that, what do we normally think of as being in the entity store? Well, it's a version of all of the authorization relevant state. So that often scales with the number of resources or the number of users. And for a really large, flagship enterprise scale app, you could be talking about tens of thousands, hundreds of thousands of entities. And you don't want to have to ship the entire entity store every time you make an authorization request.
Yeah, I'm
You
drawing a
also,
little picture here where you have some
yeah,
table of users and there's like 10,000 more down here.
and you also have to be able to update these things, right? Because your entity store is going to change as application state changes. So what part of that entity store do we need for a given request?
Right, maybe you just need this one row for a given request because all your Cedar policy cares about is like this particular user or something like that. And sending this whole table is correct from Cedar's point of view, but really you only needed this one row. That's the problem that entity slicing tries to solve.
Cool. Do we have an example?
Let's see. I have an example here that involves users and documents, so maybe I could go through that.
Yeah, can you
So
bump the
it's,
font size a couple of levels?
yes, great idea. Is that good enough?
That's perfect.
Right. So here is an example where a user has some metadata, like oh, sorry, a user doesn't have any associated data, but a document has an associated metadata and a set of readers. And there's only one action, and that's reading documents. Oh, sorry, there's two actions, reading documents and editing them. I'm like reading back an example I made
Yeah,
super
yeah,
long
yeah.
ago. And the user can do that action to the document. Great. And what we want to know is sort of what data is required when you do a read and what data is required when you do an edit. That's part of the intuition behind entity manifests is that it's going to depend on the action that you're doing um, on which data you need.
And so far, we're just looking at the schema. So we just know the shape
Right.
of
So this is
entities.
just the type check level
Right.
information. Here is the information that we're going to analyze, which is the policies, and that'll allow us to decide what data is needed. So here are some policies. This one says that documents can be read by anyone in the reader's set for the document. So if the principal is a user, the resource is a document, and you want to read the document, then if the readers contain that principal, then you can read the document. And sort of the punchline here, let's skip the other rules for now, is that Once you have a principal, action, and resource set, really the only information you need to fulfill this request is what are the readers on that document. You don't need like the other documents and those other documents as readers.
So maybe a point here is that for any given authorization request, we've already sort of ground the principal, action, and resource. Like we know their
Right,
concrete values, but we might not have fetched everything that's reachable from those values.
right.
So
And this brings us to the main concept, the solution to this problem, which is to build a data structure that tells you sort of what is reachable from these rules. And we call that data structure an entity manifest. You take all these rules that you've written in Cedar, you pass it to the algorithm I wrote, and it spits out this entity manifest thing that tells you for which types of requests what data you're going to need.
So maybe we can also, because I think, as a user, the big benefit is not fetching the stuff I don't need. So here we need the readers of the resource. But if we scroll up, resources also have, or document resources have metadata. So for example,
Right.
like we don't need to go fetch the metadata or anything reachable from that metadata, like the time. Like I don't have to
Exactly.
fetch this stuff. So these are rows that I don't need to make a query to get to do the authorization check.
Right. I think of like entities as rows because that's often how they're laid out in databases. And then these different fields are kind of like not only did we only need this one row, we also didn't need the metadata column. So we can pick like these columns. If you were writing some SQL or some database query, you would tell which columns for that row that you need. And this is sort of doing that same thing. It's analogous to a query.
Got it. Got it. Got it. And so far, we're talking about this from the perspective of a single policy, but I assume we'll
Right.
generalize this to policy sets.
Right. So if you analyze sets of policies, it turns out that just unioning the resulting entity manifests gives you the one you would want to use for all of them. That's
Got
the
it.
nice property. So say you have like 1,000 policies because you're a giant organization and everyone's writing their own policies, and you add one more. All you need to do is compute the entity manifest for that one more and add it to the big compiled result.
I see. So this analysis is incremental and
Yes,
parallelizable because I can analyze each policy in the policy set independently.
exactly. It's very, very nice in that way.
Okay, Oliver, this sounds like good stuff, but what the heck is an entity manifest?
Right, that's a good question. And the answer is that uh, in your mind, you can think of it as just a big list of these data paths that we need. But they're indexed on their request type. So if you are a user trying to read a document, it's just this big list of all of the data paths that we need.
And what's the
Um,
double star on ancestors mean?
this one, I meant to say that in Cedar, there's something called the entity hierarchy. I think you may have seen it in previous episodes of Cedarcraft. But we handle it specially because it is a special thing. So this is saying that ancestors isn't a field of principle. It's like the
Everything above it,
actual
everything that
ancestors in
contains
the
that
entity
principle.
hierarchy. Yes,
Right,
yes, exactly.
right, right. I
Yeah,
see. And it also looks like there's some sort of type specialization here in the sense that there could be, I see. So here you're saying for any request where the action is read and the principal and resource have these types, then you might need the following. In this
exactly. So
case,
you need to
this
know the type of your request, and you need to have a schema that the policies validate against, because without type information, we can't really take advantage of that specialization.
got it. Got it. So the way that I would use this manifest, presumably, is let's see. There's somebody hits an endpoint in my application.
Right.
I am going to do an authorization request. I know the types of the entities and I know what the action is because it's concrete. And I know that actually I know the whole thing. It's all concrete. And so I know their types. Then I look in the manifest. I find in the manifest some request type that matches this. And then the data required is basically telling me like a SQL query or a MongoDB query or something to execute to get all of the relevant entity store I should send along with the is authorized call to Cedar.
Well, that's a great question. Let's make it a lot more concrete. How would you actually use an entity manifest? because I told you this is a list of data required. Under the hood, it's actually stored as a compressed like trie data structure,
Mhm.
but you don't really have to know that. Um, but pretty soon this will be an experimental feature once this PR goes in. And once this goes in, you'll be able to implement this one trait and get entity slicing for free. So here we have the
Hang
entity
on, hang on,
loader
hang on.
trait.
You get it for free?
For free? Well, no, not really. But you have to implement this trait and then it just works. That's my
That's really
claim.
surprising. So interesting. So if you're using the Rust bindings, and when you say you implement this trait, who implements it?
The
Like you
user,
implement
yeah,
it,
yeah, yeah.
but
You,
like is
the
it for
person who
your
wants to use
policy
Cedar.
for like a trait on what? Like what is it
Yeah, I'll describe the trait and
okay,
then
okay.
maybe it'll make sense. So like all that entity manifest stuff that I showed in here was sort of like internal details. The main thing that people wanting to use this actually care about is this entity loader thing.
Mm.
Because once you know how to implement one of these, it just works. So to implement an entity loader, ignore load ancestors for now. The default way you would use this is to implement a single function, which is load entities, and it gives you a batch of entity requests, and you return a batch of entity answers. And an entity request is basically just the ID of the entity we want you to load. So this thing, the access trie is optional. You can ignore it. You can just look at this entity ID, load a single entity, and that's all the code you have to write. Based on that entity, the underlying engine will follow all the pointers, ask for more entities, and keep doing that until you've loaded the necessary entities.
I see.
If you
And
want to get fancy, yeah, if you want to get fancy, you can look at this trie and load only some columns or fields in your entity.
your analysis is going to compute that try for us.
Yes, the trie, you call my analysis, you get the
Yeah.
trie, you
You
implement
plug
this
it in
loader.
there.
Yeah. Then you call, there's like one entry point, if I can find it. There's like a load entities endpoint that you call with your implementation and the entity manifest, and it does this.
And since this is a trait, that means you need to do this statically. Like if I update my policies, I'll need to recompile.
Well, this doesn't depend on your policies at all.
But the try does.
The try, it gives you the try in the request. So if you update your policies, you need to update your manifest,
Yep.
but that manifest, this entity loader thing, in
I
my
see. It's
mind,
going to
doesn't
get
have
it
to
each
change.
request. Got it.
Yes, yes. The
So I don't
loader
need to
knows how to
recompile.
load a single entity. The entity manifest needs to be recomputed when you change the policies.
Got it.
Yeah.
Cool. Okay, so we have entity manifests, which are an over approximation of all the data we might need to decide authorization for a request, given the types of the principal, what the concrete action is, and the type of the entity. You can automatically compute the access tries, which describe all the things that we might need to grab. And even better, if somebody just implements this type class, then this is all going to work for them automatically, and they'll request much less data from the entity store to check authorization than they would otherwise need.
Exactly. This API is super convenient. There is one downside, and that is if you care about database consistency, you want to like do all your loading for a request at once so that you don't get an inconsistent view of your database, then you might not want to use this entity loader because it's going to call this batched thing multiple times, and your database may have changed in between those calls. So if you care a lot about database consistency, you might want to uh, compute a query from the entity
And then
trie directly.
reuse. Sorry, so basically you want a single consistent view of that data.
Right,
Right now, it might actually make multiple queries.
right. This
And if
is
the database is
convenient.
mutated in between, that's bad
Yeah,
news.
yeah. This is convenient because it does batches of multiple queries. It handles the like joins for you, in my mind. It follows the pointers for you without you having to do anything. If you want to get a consistent view of your database, you have to do the wrangling to make that join work.
And with a batch, I mean, so I have an access try for each request, authors
Right.
like is authorized request.
Right.
If I have a batch of those, now for each one of them, I have a trie. So I just merge those tries and I take everything that matches all of them. Does that introduce additional records I wouldn't need if I'd done them individually, or are they all handled independently, separately?
I think unifying tries gives you exactly the data from both of them.
Right.
So they're pretty precise, is what I'm trying to say.
Yeah,
They don't give you extra information just because you unified them together.
I see.
Yeah. And this batch API is because you want to do fewer calls to your database. So
Exactly.
that we do a breadth first traversal of the try to try and reduce the number of calls.
Got it. Got it. Got it.
Yeah, I think
Cool.
it's the minimum number actually.
Oh, nice. So do you have a sense, sort of maybe back of the envelope, for how much savings on querying the entity database the manifests overall provide? Like, I mean, I guess that the baseline, the naive baseline is you query the entire entity store every time for every request, and then you just use a tiny
Right.
piece of it.
That is the
Um,
baseline I used, but like it's sort of like I can make it as bad as you want because you probably in practice have lots of data.
right.
But also I looked at some realistic examples. So Cedar has these Cedar examples repository with all of these different realistic use cases from real customers, compiled in as like a bunch of different examples. And I manually went through all of these and looked at which data you would actually need. And at the bottom of this RFC is all of these examples split out by the type. And what I found is that all of the tries for these realistic examples are very small. So in practice, you would need like 2, 3 entities compared to your whole entity store. And when comparing to a manual implementation where we like carefully looked at the policies and thought about which entities we would need, um, it would usually match the manual version, and in some cases it would find slightly more. It would find a way to load slightly fewer entities because we were too conservative, or we didn't realize we don't even need the principal entity, that sort of thing.
Got it. Got it. Got it.
So these really do in practice just load very little data. It would be interesting to see real world examples where you have to load a ton of data. One area that comes up is if you have big sets. So I showed you an example at the beginning where readers is a set of users. If this set is super large, right now the entity manifest will load the whole thing. But really, if you look at this example,
You
we
know
only care if
inequality.
that's, yes, we only care if that set contains principal. Right now, that sort of information where we're reasoning about sets is lost. But I think some tweaks to the analysis and extensions to the tries could make that work.
So maybe just for intuition, right now what you have is you're sort of, rather than selecting, every row, like all the columns in every row of every table, you're figuring out a smarter where clause for what tables and what columns of those tables you need from the entity store.
Right, exactly.
Or sorry, select clause. It turns out that you could also have a where clause to further constrain that. So in this example where, like you said, resource that contains, you'd say something like, I mean, I guess you don't normally have the set directly, but there's this equality constraint that you could additionally check and pull out even more data
And some databases have the set
or less data.
directly. So you would want to say like, don't load that whole set, just load
Yeah,
the principal element from that set. And that would be useful. I
right.
think besides sets, there's literally nothing else that's not precise. Like the entity hierarchy, it tells you all the
It's
information it
minimal.
could. Yeah. Besides loading sets, we're good. That's the only data structure in Cedar
So you
that
mentioned
exists right now.
the entity hierarchy, which is helpful for a lot of uh, policies. How does that work with entity manifests?
That is a good question. Maybe I should draw a little picture. So someone on this thread when I made the RFC asked this question, and at first I thought it was hard, and then I realized there's a nice little trick you can do. Let's go back to my picture. Uh, I'll just Control Z. Great. So what is an entity manifest as I've described it so far? It is this try thing, and uh, each edge is annotated with a data path. You can see this, right, Zach?
Yep.
Great. So this would be like principal. And this would be like some attribute on principal, like maybe name.
Right.
And it turns out that one of these things, like maybe this node right here, we need some ancestors. But the question is, which ancestors do we need?
And the way you can tell if you need an ancestor is if that's the left-hand side of an and operator.
Yes. So did I show any examples here? I did not. Yeah, but an in operator is asking Cedar about the entity hierarchy. It means if it's a descendant.
Right.
So when we see an in operator, we do our usual analysis on the right-hand side to see what data paths we care about. And then it turns out that those data paths are already somewhere on this trie. So to support ancestors in our entity manifests, all we need is a set of pointers to existing nodes in this trie.
So hold on.
Saying
The
like
reason they're
these,
already in the trie is because you computed the trie for the whole query, and in particular for the
yes,
right-hand side as well.
yes, the right-hand side is already on. This is sort of a subtle invariant.
Yeah.
Like the whole thing gets analyzed, so everything must go in the trie. Therefore, the ancestors of this are already in that trie. We just
Right.
need to add the relevant pointers.
Right.
And this gets back to something I told you to ignore earlier, which is this load ancestors part of the API. So now that we have these pointers to other things in the trie, we can separate out loading the ancestors from the entities. So instead of loading all the ancestors right here, you can optionally delay loading the ancestors, load the whole trie. This will get called multiple times. And then this load ancestors endpoint gets called exactly once, and it gets called with ancestor requests, which tell you which ancestors we care about.
I see. Will you already have all of them though?
Yes, so we load the whole trie.
So when you do
Well,
load ancestors in that trait,
right.
does it just give you back a subset of things you've already fetched?
So the idea is that when you fetch this entity the first time,
Mm-hmm.
you don't load any ancestors.
Right.
You just load the entity. And then when load ancestors gets called, it tells you, hey, if these ancestors are present, these are the ones we care about. You don't have to load any others.
I see.
So you'll look in the set for this node and you'll find those ancestors. So this does have like the disadvantage of you're going to visit this node twice.
Mm-hmm.
Once the first time it goes down the tree, and then once to grab its ancestors.
Sure.
And if those ancestors were already right there, you might consider just loading it the first time. Or and the reason we can't do it right away is that we don't know what order these things are loaded in, and in general, there may be like cyclic dependencies.
Well, and in particular, you don't want to know because then you'd have to evaluate the queries in a certain order. It's nice that they're independent.
Yes,
It
it is
makes it
nice that
much
they're
easier to
independent.
execute. You that independence, provides a lot of flexibility to optimize for the execution
Right.
engine, right?
Under the hood, this isn't actually stored as pointers to other nodes because that's very messy. We actually just store another trie that's a subset of this one.
Sure.
So it would be something like this with these blue arrows. But you can think of them as like just pointing to these other nodes.
Cool. Okay, so we've got manifests. We can support the whole language, can fetch way fewer entities, way less entity data than we would be able to without it. And we know that it's correct too, I guess. I mean, because you can imagine people trying to implement that trait without your tries, just by eyeballing their policies and their schema and hoping that they get enough stuff. But your algorithm guarantees that we're never going to miss something that would change the outcome. Like that is, if I use your analysis, I'm guaranteed to get the same answer I would as if I sent the entire entity store on every request.
Right. There's sort of a correspondence. Like there's like the world in which you, for some request, oops, for some request, and you put like the whole database over here. The answer you get, yes or no, should be the same as if you gave it the request, the entity slice, so maybe just one row. and these should match up.
Right.
Yeah.
Right. So when is this going to land? I mean, you showed the PR. Is there a ETA? Like, do you have a sense of when people will be able to start? I guess they could play with it now if they just check out your branch.
I think it's going to be an experimental feature landing within weeks. So
Cool.
I already merged the first PR and the Cedar team just released Cedar 4.0. So that's awesome.
Yeah.
And now they have time to take a look at reviewing my PRs and getting them merged.
Nice. Nice.
But
Nice.
it won't be a while until it's a stable feature. So Cedar doesn't consider features stable unless they have formal proofs of correctness. This is part of its super high guarantee about your answers being correct. So unless we have those formal proofs in lean, it won't be a stable feature. It'll be experimental for a long time.
Do you have any plans to do that lean proof or know people working on it or ideas about uh, somebody who's curious what they might look at for that?
I heard something about that it'll become someone's job to do
Oh,
those
cool.
formal proofs. Yeah. It'll be
So
tough though, for sure.
sure. So people can experiment with it soon, but if they want to restrict themselves to only stable features, it might be a little bit longer.
Yeah, and to be fair, like it is pretty compared to other software projects, I already have a much higher confidence that this is correct because we've done lots of unit testing and even differential random testing with
Right.
a fuzzer. I
Well,
found two subtle bugs by doing that fuzzing.
and you basically already described the fuzzing strategy right here, right? I mean, give the whole thing, give the slice thing, make sure they agree.
Exactly. All the fuzzer does is do these two requests and make sure they agree. And
Yeah.
it found a discrepancy, and I was able to fix that. It was something like the has keyword in Cedar means that that attribute might not actually be there, and I wasn't handling that correctly.
Yeah. The random differential testing in general in Cedar, I've been amazed at how effective it is. It's
It
just
was very easy to set up too.
yeah,
I
it's
just
really
hooked into
slick.
the already generated thing, wrote the little code that does this check, and it was done.
So maybe kind of wrapping up here a little bit. I'm hoping to do another episode soon, talking with folks about open source contributions to Cedar. And we haven't done that sort of big picture episode yet. But you're showing these PRs. What's your experience been? I mean, we just mentioned that there's all this testing infrastructure that's really helpful. But how would you compare this to other open source projects that you've hacked on, or what are you any tips for somebody who's curious about getting involved in Cedar development?
Right. I would say I've been very impressed by the Cedar team. The code is really high quality. They're very responsive. The RFC process is transparent and good. I would say like if you want to contribute something, there's lots of issues that new people could take, and we treat individual contributors outside of Amazon just the same as Amazon employees. So you can go ahead and put up PRs and a lot of the automated checks will help guide you in the right direction before humans take a look at it.
Cool.
So yeah, and the RFC process is pretty neat. If you take a look at the flow chart for how RFCs work, that's another helpful thing to do if you're planning on like contributing a big feature.
That's helpful. That'll give me something to make sure that we ask about when we talk to other people about open source contributions in Cedar. Well, Oliver, I think that's kind of all the stuff that I was super curious about. Really excited for this entity slicing feature. Thanks so much for taking the time. Anything else that you wanted to say about entity slicing or Cedar broadly?
Nope, I just hope more people use Cedar because I think it's really useful.
Agreed. All
So,
right, folks. Make sure to tune in for the next episode of Cedarcraft and have a great day. Take care. Bye bye.
bye-bye.